Hi everyone, today's lesson is on hyperbolas, conic section. So let's get started. So the first thing we're going to do is we're going to start off with a warm-up. Find the equation of an ellipse that have vertices 3, -4, 3, 6. And the endpoints of the minor axis are 1, 1, and 5, 1. So let's graph this first. So we've got 3, -4. So we have 1, 2, 3. And then -4, so we'll say that's about right there. And then we have 3, 4, 5, 6, or excuse me, 3, and then 6, which is up here. So this value here is 3, 6. This value here is 3, -4. And so we know that because those are my vertices, those are going to be on my major axis. And so those being on my major axis, what I would do is I would find the distance between these 2 points. In doing that, that's going to give me my center. So what I would do is I would add, this is 6 here, and this is -4 here. So that means that that's 10. The distance of my major axis is equal to 10. So that means A is 5. So 1, 2, 3, 4, 5. I need to figure out where am I at 5 down from 6. It looks like if I count 5 down, I should be at 3, 1. So there we are at 3, 1. So in doing this, I'm going to move that down just a little bit to make it look like 3, 1. In addition to that, I have a minor axis points at 1, 1, and I have points at 3, 4, 5, 1. And this is my minor axis right here. So for me, this looks like the distance between here and here, my minor axis vertice and my center is 2. So that's my B value. And then I have my major axis, which is this distance from here to here, being 5. And that's my A value. So additionally, this being 3, 1, that's my center, which is inside there. So my center is at 3, 1. So that value here is this value here. So we're going to start our equation by going x minus 3 quantity squared plus y minus 1 quantity squared equals 1. And so to find the standard form for the equation of an ellipse, looks like the major axis right here, which is the length of 10, meaning the A value, because the major axis is 2A. So 2A equals 10, so that means A equals 5. That's always going to be the longer axis, and it looks like that's on my Y axis, so that means that A squared, which is what's going to go down here, is 25. For my B value, which is the smaller axis, which goes along the X axis, okay, that's going to be 2 to the left and to the right. So this distance is 2, which means B squared is going to be 4. So the equation of my ellipse in standard form is this right here. Okay. All right. Warm-up number 2. For the ellipse, find the center, the vertices, and the foci. For this problem, we're actually going to have to complete the square. Now remember, completing the square means that your x-coordinate has to be 1. And if it's not 1, then you have to factor that out temporarily and then put it back in at the end. Likewise, the y-coordinate also, the y-squared coordinate also has to be 1, which means we're going to temporarily have to factor out this 4. So let's group our x's and y's. So first we're going to have 25x squared minus 250x. And now grouping my y's, I'm going to have plus 4y squared minus 16y. And I'm going to move this 541 to the other side, so I have negative 541. So what we have now is we're going to have to complete the square, but remember again, your x-squared coordinate, this one right here, your A term, has to be 1. It has to be 1, so we're going to factor that out. So we have 25 times the quantity x squared minus, taking 25 out of that gives me 10x. Now, we can complete the square since my x-coordinate is now 1. So half of 10 is 5, and you take -5, square that, you get 25, okay? Plus, now we're going to factor out this 4 temporarily, so we get y squared minus 4y. Half of 4 is 2, 2 squared is 4, so we're going to add 4, and is equal to negative 541. But remember that if you add something to the left side, you have to add the same value to the right side. And in this case, we're adding 25 times 25, which is 625. We're also adding 4 times 4, which is 16. So simplifying, we get 25 times, factor this out, we get x minus 5 times x minus 5, so that's x minus 5 quantity squared. We are factoring out, we have the 4, so we go y minus 2 times y minus 2 quantity squared. And we have negative 541 plus 625 plus 16, and that's equal to 100. Yeah. So then, putting into the ellipse standard form, this value right here needs to be 1. So what we're going to do is we're going to divide everything by 100. Divide everything by 100. And what happens here is this becomes 100 divided by 25. This becomes 100 divided by 4 over 1. So basically you're multiplying by the reciprocal. And this is equal to 1. So we get x minus 5 quantity squared over 4 plus quantity y minus 2 quantity squared over 25 is equal to 1. And it looks like my major axis now for my ellipse is going to be my y-axis. So remember my center, so you're going to write down all these values. My center is going to be at parenthesis 5, 2. My major axis is always going to be 2 times a, being the bigger value, that's a squared right here. So a is 5, so 2 times 5 is going to be 10. And my minor axis is going to be 2 times b, this right here being b squared, so b is equal to 2. 2 times 2 is 4. Lastly, we need to find the focal points, and where my foci, in order to find my foci or focal points, I'm going to use the formula c squared equals a squared minus b squared. In that c is what we're looking for because we already have a squared, and we have a squared is 25 minus b squared, which is 4. So 25 minus 4 is c equals the square root of 21. So what we're going to do is, first we're going to graph our center, which is at 5, 2. So there's our center at 5, 2. In the x direction, I'm going to go the square root of 4, which is 2. So in the x direction, I'm going to go 2. Okay. In the y direction, I'm going to go the square root of 25, which is 5. So my ellipse is going to look something like this. Okay. Now, you wouldn't label the vertices, of course. You're going to need to label your vertices. In addition to labeling your vertices on your major axis, I would suggest also to label your foci. And remember, your foci are always on your major axis. And if my foci are on my y-axis, I'm going to add this value to my y coordinate. So my foci being around here, square root of 21, it's not quite 5, it's not quite 4, it's more than 4, less than 5. This value right here for that focal point is going to be 5, 2 plus the square root of 21. And my focal point down here is going to be parenthesis 5, 2 minus the square root of 21. Okay, so this whole chapter is on conics. And what we've done is this is sort of an example of letting you know what's actually happening. When you slice a cone straight across, you're going to get a circle. And when you pull that out, that's just a circle. It's round, straight. Okay, got a radii, all right? But if you slash the cone or slice the cone diagonally like this, what you're going to get is sort of an elongated shape, and that's an ellipse, and that's what we've just been talking about. If you slash a cone just on this one corner here, you're going to get this value right here, which is a parabola. But if you slice the cone straight down like this, right, you're going to get this shape and this shape. That's what we call a hyperbola. And the hyperbolas are either going to be going up like this, or they're going to go sideways like this. Depending how we're slicing the cone. So that's what we're covering today is hyperbolas. So reviewing what the difference between an ellipse equation is, and the ellipse information and the hyperbola. Let's talk about an ellipse. An ellipse, if the ellipse is not at the center, then the HK comes into effect. The HK is basically the center of my ellipse, and it's moved off of the center of the circle. You have what's called the A value, which is if this is my major axis, my A value is this distance all the way across to the endpoint, which we call a vertice. Okay. You also have the B value, and the B value is going to be smaller than A. What goes underneath here are B squared and A squared. In this case, A squared is the biggest value, so that's going to be underneath X because it's actually on the X-axis. In addition, you also have what's called foci, or focal points. The focal points are from here to here. That's this distance, here to here. That's my C value. To find my C value, which is the distance from the focal point to my center, is C squared equals A squared minus B squared. So this is the equation of my ellipse with the center at HK, but my major axis is on the X-axis. But if my major axis is on the Y-axis, you'll notice that my A coordinate is now underneath the Y value. And my B value, which would be this distance here, is a smaller axis. So that's my minor axis. You still use the same formula to find the focal points, but the difference is that my focal points are always on my major axis. And remember, when we're making our focal points, you've got this thing happening here, which is your distance 1 and your distance 2. And remember, distance 1 plus distance 2 is equal to 2a. Okay? If I were going back and looking at this, for my focal point, right, to figure out from here to here like that, if I was drawing my focal, and this could be anywhere on my axis like that, but one value is D1, one value is D2, distance 1 plus distance 2. So the sum of my D1 and D2 is equal to 2a. That's a formula that you need to remember. So today, talking about the hyperbola is, this kind of looks like a parabola, but this value here, if I were to look at this value and this value, that's going to give me a hyperbola. If I go this value here and I had another value that came across like that, that's a hyperbola. Okay. Also, hyperbolas would look like this, sideways, like this. Now, there's kind of certain parts to a hyperbola that you're going to learn. So if my hyperbola, which is sort of two parabolas, right? Okay, is definitely going to have a center. There's my center. You're going to have a focal point, but different than an ellipse, whereas an ellipse has the focal points inside, the hyperbola has the focal points outside, like that. But they are still, see that corner here? See the corner here? That's the focal points are always going to be sort of protected in this corner. Same with this, like that. See that? You also have this distance from here to this vertice right here. Okay, the center to my vertice. From my center to this vertice, this whole distance here, we call that the transverse axis. Okay. In addition to that, we have another axis, which sort of doesn't help, it doesn't connect anything, but that's called the conjugate axis. Okay, and the conjugate axis is not a minor axis. The transverse does not have to be bigger than the conjugate. They just have to be, it's just dependent on which axis my foci are on. So my foci are always on my transverse axis, whereas the conjugate axis does not have any focal points on it. Okay, so a hyperbola looks like this. You do have focal points, and so you could have, these are my focal points. They're going to be the same distance from my center. Okay, that's going to be my C value. And same with this distance here is C. Okay, this distance from here to here is A. And this distance from here to here is B. And it doesn't have to be, whereas an ellipse, the A value is always greater than B. In a hyperbola, the B value is not always smaller than A. It could be bigger. The main difference between an ellipse and a hyperbola is this. An ellipse has an equation like this: x squared over, let's say, a squared plus y squared over b squared is equal to 1. See how we're adding? A hyperbola, this is my ellipse. A hyperbola's difference is you're going to be subtracting. So a squared minus y squared over b squared is equal to 1. See how I'm subtracting? Now, keep in mind that I could write it like this, but I could also write it like this. Negative x squared over a squared plus y squared over b squared is equal to 1. And additionally, some people write it like this: y squared even over a squared minus x squared over b squared is equal to 1. So there's different ways that you can write this equation. What you're going to notice is that this equation right here, do you notice that there are asymptotes here? And so for this equation, I think, let me see if I can move this over a little bit, okay? My asymptotes are basically go from corner to corner. It's a little bit, this is a little bit off. But the equation of my asymptotes is y equals plus or minus negative b over a. So basically that's my y over my x. So it's always going to be y over x, rise over run, okay? Additionally, the focal points right here are always going to be, instead of, see how we, in the ellipse, we did c squared equals a squared minus b squared. In a hyperbola, the equation of the focal points is always going to be a squared plus b squared, meaning you've got to get it out here. So your focal points from here to here, that's your C. From here to here, that's your A. And from here to here, that's your B. Okay, but I can similarly, if you'll notice the positive x, see the positive value? That's where my hyperbolas are going to be on. Well, that's the axis. The positive value, the positive squared term, okay? So the positive squared term is the axis where the hyperbolas are going to be on. They're always going to be on the positive. So see how x squared is positive? That means that my hyperbolas are going to be off of my x-axis. Whereas in this example, you'll notice that my y squared term here is positive. That means my hyperbolas are going to arc around off of the y-axis. See y-axis here and here. Okay? So let's do an example. We're going to also state the vertices, the focal points, and the equation of the asymptotes. So what we have is this equation right here, okay? With this equation right here, what we're going to do is we're going to try to find all the values that we need to graph this. So we know that because there's no HK here, meaning it looks like, see how it could have been x minus 0 quantity squared minus y minus 0 quantity squared? What that means is that that's 9, that's 36, that my center is at 0, 0. Now, because my x term is positive, that means that my hyperbolas are going to come off of the x-axis, okay? Not sure where yet, but they are going to be coming off the x-axis because the x-axis is positive. What you do in order to figure out how to graph this is you look below this term. I'm looking below the x-axis. That value right there is where I'm going to go. That's my square root term. So you're going to square root 36. That means in the x direction, I'm going to go 6 to the right and 6 to the left. So in the x direction, I'm going to go 6 this way and 6 this way. Okay, and that's where my point's going to be right there. For my y coordinate, I'm going to go 3 because I'm going to go the square root of 9, which is up 3. So 3 up, 3 down. Now, I know it's really easy to want to make an ellipse, but you've got to notice that this is a minus. And what that means is what we're going to do is it's going to be a hyperbola. And what I suggest is either you create a little box like this. I think this is easiest to do this way. And you put in your asymptotes like this. They go from corner to corner. Okay? Like that. So that in creating my hyperbolas, because it's on the positive axis, my hyperbolas are going to go like this. Follow your asymptotes. Okay, so follow the asymptotes. Goes like this. Okay, so we just finished graphing our hyperbola. Now, a couple of things that you need to note. Number one, the axis that connects the two vertices, like this, that's what we call the transverse axis. So that axis is the transverse. You're going to need to know that. The transverse axis has length 2 times 6, which is 12. So the transverse axis length is 12. The conjugate axis is the axis that really doesn't connect your two vertices, but it does help you to graph this. So that means that this axis right here is my conjugate axis. Okay? Conjugate. All right. So, and additionally, we know our vertices. We know our vertices are at 6, 0 and negative 6, 0. We need to find our focal points. So first we need to find what the foci is. So the foci is going to be c squared is equal to a squared plus b squared. We have a squared and b squared. So we go c squared is equal to 36 plus 9. So c is equal to the square root of 45. So c is equal to 3 root 5. 3 root 5. So that means that I'm going to go approximately 3 root 5 to the right and 3 root 5 to the left on my x-axis. So in order to find where that point actually is, now remember, you're always going to add it to if it's on the y-axis, you add your foci to your y-coordinate. If it's on the x-axis, you add your foci to your x-coordinate. So in this case, we would go 0 plus 3 root 5, and 0 minus 3 root 5. So this will be negative 3 root 5, comma 0. And this focal point would be 3 root 5, comma 0. Okay? Lastly, what we need to do now is we need to find the equations of the asymptotes. Now, the asymptotes are going to be plus or minus, so y is equal to plus or minus the y over the x. It's always y over x. So it's going to be square root of 9, which is 3 over 6. So plus or minus 3 over 6 x. Now, that is the same thing as going up 3 over 6, but at the same time, I can reduce that, and that's going to be plus or minus 1/2 x. So those are the equations of my asymptotes for this hyperbola. Cool. Okay. Second one says, find the equation of the hyperbola that has vertices of 0, negative 8. So we have 0, negative 8. So let me write that down. And 0, 8. So 0, 8 up here, which means that what that means is that directly in the middle is 0, 0. Oh, hold on a second. Going back, I didn't have to figure out where the y minus. Notice that because this was a positive coordinate, that my hyperbola is on my positive axis, being x-axis, whereas this one, be careful, because what we know is, so far we know our coordinate is 0, 0. So meaning it's going to be x minus 0 quantity squared, so that's going to be x squared. We know we have a y squared. We know that we're going to have an equal to 1. We know that the foci, or our focal points, are at 0, negative 10. So this is my focal points at 0, negative 10, and 0, positive 10. Well, what that means is this, that my hyperbola is always going to cup my focal points. See that? So it has to look something like this, which means that my hyperbola is on my y-axis, which means that my y-axis is my positive term, and that means the x-coordinate is going to be negative. Additionally, that means that this value right here is my a. It means this value from here to here is what we have called the transverse axis. So from 0 to here, that's a, which is 8, okay? So that in the y direction, this is in the y direction, so 8 squared would be 64. I know that my focal points are at 10 and negative 10, so that means C is equal to 10. So we're going to go with this formula, C squared is equal to A squared plus B squared. So my C, so we're going to have 100 is equal to my A squared. And in this case, your A squared is 64 because that's your positive axis plus B squared, which we don't know. So we know that subtracting 64 is going to give me 36, which means that underneath the x-axis is 36. Now, the only other thing, because this is my equation of my hyperbola, which we have graphed, the only other thing that I would suggest is there is another way to write this. And depending on who your instructor is, what book you're using, a lot of people in books like to put the y coordinate first. They like to put the positive coordinate first. So you would write y squared over 64 minus x squared over 36 is equal to 1. And so this is also the equation of my hyperbola, but I don't really have to do anything. I mean, I would take either one for the equation of my hyperbola. So for this one right here, for the given hyperbola, find the standard equation, find the vertices, figure out where everything is, the asymptotes, and also graph. For this problem, you actually don't have to complete the square, because remember, you only have to complete the square when you have an x squared term and an x, or a y squared term and a y. But because you don't have that, you don't have to complete the square. So realistically, all I have to do is divide every single term by 144 in order to get this to be 1. And so remember, when you're dividing, you're actually multiplying by the reciprocal, meaning this is actually 144 divided by 9, and this is 144 divided by 16. And in this case, I'm going to get x squared over 16 minus y squared over 9 is equal to 1. So here's my equation of my my hyperbola in standard form. It looks like my center is at 0, 0. And in the x direction, I'm going to go 4. I'm going the square root of 16, which is 4. So 1, 2, 3, 4. 1, 2, 3, 4. And in the y direction, I'm going the square root of 9, which is 3. 1, 2, 3 up and 3 down. What I don't know, technically, is which axis is my hyperbolas on? Which axis are my hyperbolas on? Now remember, your hyperbolas are always on the positive axis. So in order to help you graph this, you can either graph by asymptotes, which is completely fine, or you can graph by making a little box that goes around this, drawing in your asymptotes box to box, corner to corner, like that. And remember, your hyperbola arcs are going to follow the asymptotes, okay? And in this case, because my x-axis is positive, my hyperbola is going to go this way, and it's going to go this way. Likewise, it'll start here and go this, because again, my x-axis is positive. Now, two things. I could have graphed by asymptotes, meaning y is equal to plus or minus my y square root of my y coordinate over my x, which is 3 over 4. Okay, and so that's the equation of my asymptotes. And a lot of people will graph that way by starting at 0, 0, and going up 3 and over 4. Completely fine. Those are your asymptotes. You would also go up 3, left 4, down 3, left 4, down 3, right 4. Additionally, we need the focus points. So we're going to go c squared is equal to a squared plus b squared. So that's going to be c squared is equal to 16 plus 9, which is 25, and that equals c squared. So c equals 5, which means that if I'm going to the right 5, I have a focal point here, and that focal point is at 5, 0. And this focal point, sorry, that's not my focal point. And my focal point here is at negative 5, 0. My vertices, which I will put in blue, my vertices are 4, 0 and negative 4, 0. Trying to think if there's anything else we need. Asymptotes, we got our focal points, we have our vertices, and our center is at 0, 0. So what happens when the center is not at the origin? That's when your HK comes into effect, and your focal points are still at a squared plus b squared. Your transverse axis is always going to be your positive axis. So this would be your A value here. Here, do you see that? Your conjugate axis is your negative value. It's the other one. So what we're going to do is we have this equation right here. We see that, see the y squared minus x squared? If you have a minus sign in between here and here, this means it's a hyperbola, not an ellipse. An ellipse will have a y squared plus x squared or an x squared plus y squared. So we're going to complete the square. So let me see how many times we're going to complete the square. We have an x squared term and an x, and we have a y squared term and a y. So I'm actually going to complete the square 2 different times. Okay, I'm going to write this out with the x squareds first because that's how I like to write them. When you complete this square, you can complete them with the y's first or the x's. So we're going to go negative x squared plus 4x, and then I'm going to say plus 4y squared plus 24y is equal to negative 28. So what I've done is I've grouped my x's and I've grouped my y's, and I moved this 28 to the other side. Because when you complete the square, this value is not necessary to be next to where we're at. Remember, when completing the square, though, your x squared term and your y squared term have to be positive 1. In this case, it's not positive 1. So what I'm going to have to do is I'm going to have to factor out that negative sign. So in factoring out that negative sign, remember you're dividing out a negative sign temporarily because we are going to put it back in. So we take out that negative sign. This makes this a negative 4x. And then now I can complete the square. Half of 4 is 2. 2 squared is 4. So I'm going to add 4 to this side. Completing the square on this side, I'm going to get a positive 4 times the quantity, factor out that 4, y squared plus factoring out 4 from 24 is 6y. Now complete the square. Half of 6 is 3, 3 squared is 9. And then you have equal to negative 28, but don't forget, okay, this negative 28, you have to add in whatever you added on the left side, it has to be adding on to the right also. So see this negative 1 times 4, I'm going to have to add in a negative 4. Additionally, I'm going to have to add in this 4 times 9, which is a positive 36. And so what this does for me is it gives me negative times the quantity. Factor this out. So we're going to get x minus 2, so minus 2, quantity squared. A step that I'm not showing here is this step where when factoring this out, I would get x minus 2 times x minus 2, like that. But because they're both the same value, and that's going to happen every single time because you're forcing this to be a perfect square. It will be a perfect square. So it's quantity squared. Plus 4 times the quantity, factor that. You're going to have y plus 3 and y plus 3, quantity squared. What is that? 4. I guess that's 4. So what we have now is almost an equation in standard form. But for this to be an equation in standard form, this value has to be 1. Also, you can't have anything by your parentheses, technically any numbers. So what we're going to do is we're going to divide everything by 4. And in doing that, what we're going to get is negative times the quantity x minus 2 squared over 4 plus this is going to cancel out. That's 4 divided by 4. So we're going to have y plus 3 quantity squared over 1 is equal to 1. And so this is my equation in standard form for my hyperbola. Now remember, again, a lot of people will put the y coordinate, y value first. Doesn't matter. My center of my hyperbola, and the reason why I know this is a hyperbola and not an ellipse is because I do have a negative sign, whereas an ellipse will be positive, positive. So my center is going to be at, remember, opposite, opposite, positive 2, comma, negative 3. And so let's graph that. So positive 2, negative 3. So there's my center. In the x direction, I'm going to look right underneath the x value. Look at the bottom. That's how much, the square root of that is how much I'm going to go in the x direction. So the square root of that is 2. So in the x direction, I'm going 2 to the right, 2 to the left. In the y direction, I'm going to look underneath y. There it is, 1. Square root that, 1. So in the y direction, I'm going to go up 1 and down 1. And what I'm going to do is I'm going to make my little box, because I do like to make the little box that surrounds this. Now remember, don't connect the vertices, because don't connect all these vertices, because that would make it an ellipse. And it's not an ellipse because you have a negative sign. The negative sign is what makes it a hyperbola. Okay, which value is positive? See, my y value is positive, so therefore the positive axis, if it's positive, that's the axis that my hyperbola is going to be on. So I'm going to put my asymptotes in. Okay, I'm going to put my asymptotes in. Then we're going to go on the equation for the asymptotes. The equation for my asymptotes are y equals plus or minus. It's always the square root of the rise over the run. Square root of 1 over 4. Square root of 1 is 1. Square root of 4 is 2. So that's my equation of my asymptotes. Oh, I think I forgot to put an x on the other one. Let me go back real quick. Oh, yes, I did. Plus or minus 3/4 x. Okay, so here we are with our equation of our asymptotes. And the biggest question that you should have is, which axis are my arcs on? And it's always going to be on the positive axis. So what we're going to do is, because y is positive, I'm going to put, there's my vertice. It's going to follow the vertice from here to here, like that. It's going to follow my vertice from here. It's going to follow my asymptotes like that. And so there's my hyperbola. The hyperbola is just this red arc here and here. So lastly, the only thing we still need to find are my focus points. So first I need to find my foci, and that's c squared equals a squared plus b squared. Okay. My a squared is my positive value, so that's going to be a. So that's going to be c squared. C squared is equal to 1 plus my b squared term, and that's going to be 4, which is 5. So c squared equals 5, so c equals the square root of 5. So that means that from here, I'm going to go, because it has to be on the transverse axis, right, which is this axis right here. So it's going to be root 5 up and root 5 down. So that's going to be my focus point. So keep in mind, if my focus points are on my y-axis, I add it to my y-coordinate of my center. If my center is at positive 2, negative 3, then my focal points are going to be at 2, negative 3 plus the square root of 5, and this point down here is going to be 2, negative 3 minus the square root of 5. And lastly, I guess my vertices are these points here. And so you're going to label those. Remember, the conjugate axis is the axis that doesn't hold the arcs for your hyperbola, but your transverse axis is the axis that does hold the arcs. So find the equation of a hyperbola that has vertices of 3, 5, and 3, negative 1. So that means those are the vertices are the points that hold my arcs. So I'm going to draw my graph first. I'm going to draw in my vertices, and that's going to be 1, 2, 3, 1, 2, 3, 4, 5. So I've got this point right here at 3, 5, and then I've got this point at 3, negative 1. What I see is that the distance between here, that's going to be my center. So if this is 5 up and 1 down, that's a total of 6. Half of 6 is 3, which means that I'm going to go down 1, 2, 3. This is now my center, which is now at 3, 2. So what I do have here is a vertice will hold my, those are going to hold my arcs. So my arcs are going to go like this. I'm not quite sure if they're wider or skinnier, because I got to wait for my asymptotes to figure that out. So what I do know, though, is that this distance here is 3, and that's equal to my A value, my A being my positive value. In this case, it's y. So what I see is that my positive value is y. This equals 1. My center being at 3, 2. So we're going to go x minus 3, quantity squared, and y minus 2, quantity squared. I know that because my y-axis is holding my arcs, that's positive. That means my x is negative. In the y direction, I went up 3, which means that a squared is 9, and that's underneath the y-axis. Now, I know that my conjugate length is of 4. So that means that the length going across this way, that's not really holding anything, but it would make my box, right? That's 4, which means that over 2 over 2, because that whole length is 4. So if this is 2, that means that 1, 2, so this would be 4 right here. So the equation of the hyperbola is this right here. I always like to write down the equation of the asymptotes, which is going to be y equals plus or minus the square root of the y over x. So you can write it like this, see, it's 9 over 4x, but you can do a lot of that in your head too. The square root of 9 is 3, square root of 4, 2, x. It's always going to be y, rise over run. So meaning up 3 over 2. So what that did was that gave me the corners of my box. All right, cool. So what happens when Mr. Ellipse meets Mr. Parabola? Well, what's going to happen is actually we're going to be finding that out pretty soon. But since we haven't covered parabolas, we don't know yet. But what we do know is we could have a line. So this is my equation of my line. And this is a hyperbola. Now remember, it's a hyperbola because of this minus sign, but you still have an x squared and a y squared, but you have a minus. So what we're going to do is we're going to figure out what happens when those two terms are going to intersect. So let's figure that out. What we have is a line, which is y equals 2x minus 1. So I'm going to graph that. So down 1, up 2, over 1, like this. There's my line. Okay, there's my line. I'm going to draw that. It's a solid line, okay, like that. Now, I have my hyperbola. Personally, I like to write the x squared term first. Not everybody likes to do that, but I do like to do that, even though it's negative. I'm going to divide by 6, and by dividing by 6 on all sides, what I'm going to get is negative x squared over 2 plus y squared over 6 is equal to 1. It means that my center of my hyperbola is at 0, 0. It means that in the x direction, I'm going to go the square root of 2, which is pretty small, okay? And in the y direction, I'm going to go the square root of 6, which is also pretty small. So what that does is that gives me some sort of approximate box like that. It's going to give me some asymptotes this way, none of which are my hyperbola. And it's going to give me a hyperbola because the x squared term is negative. My hyperbola is actually going to arc up this way, okay, and also this way. Now, in my graph here, which is obviously just a sketch, it really doesn't show that there's any intersection points, but I could have an intersection point here if my graph is off just a little bit, or my graph is off a little bit, it could be like that. So not knowing, graphing isn't necessarily the best option. It's not always the best method, but what we can do is solve this algebraically. And by solving this algebraically, what I'm going to do is I'm going to plug in my y equation right here, what y equals, in here for y. And I'm going to try to solve this system of equations and try to find the intersection between my hyperbola and my line, if there is any actually at all. So if y is equal to 2x minus 1, y squared, so we're going to go 2x minus 1 squared. Okay, I'm going to try to draw that a little bit more straight. So let's see here. We're going to go, let's see here, let's do that. So we're going to go parenthesis 2x minus 1 squared minus 3x squared is equal to 6. We're going to multiply that out. So that's 2x minus 1 times 2x minus 1 minus 3x squared. I'm going to subtract 6 and equal to 0. It is quadratic, so you do want to set it equal to 0. You're going to get 4x squared minus 2x, which is minus 4x. Negative 1 times negative 1 is plus 1. We have a minus 3x squared, and we have a minus 6 equals 0. So combining my x squared terms, it looks like I have 1x squared minus 4x, and then 1 minus 6 is negative 5, and that equals 0. I'm going to factor this. X minus 5 times quantity x plus 1 equals 0. I'm going to split this up and set both of my equations equal to 0. So x minus 5 equals 0, x equals 5. X plus 1 equals 0, x is equal to negative 1. So what this means is I need to plug in both of these two equations in order to find my intersection points. So what now happens is, let's do that, okay? So I'm going to plug them into my y value. So it looks like plugging in this x equals 5, I'm going to get y is equal to 2 times 5 minus 1. So that's y is equal to 10 minus 1. So y is equal to 9. So when I plugged in 5, I got 9. So over 5, up 9, that means that my graph actually intersected way up here at 5, 9, meaning that this line probably came up a little bit more steep than I drew it, and this parabola did that, and it connected right there at 5, 9. Additionally, when you plug in, when you plug in negative 1, so we have y is equal to 2 times negative 1 minus 1. So y equals negative 2 minus 1. So y is equal to negative 3. So when I plugged in negative 1, I am getting negative 3. So at negative 1, negative 3. So that's kind of what looks like an intersection point. So I have two intersection points, 5, 9. And I have negative 1 comma negative 3. So those are my intersection points. So solving a system with conics is pretty cool. Lastly, last example is what happens when we have an ellipse, which is this one. Notice they're both x squared, but they're not negative. So that means it's not a hyperbola, it's an ellipse. And this one looks like a circle though. This one's an ellipse because when I divide out the 400, notice my denominators are going to be different. That's what makes it an ellipse. This, if I were to divide out 25, see that? And these are the same value, that makes it in a circle. But when I divide out the 400 on both sides, see there? That's going to be x squared over 25 plus y squared over 16 is equal to 1. See how my denominators are different? That means that that's an ellipse, whereas this is a circle because the denominators are the same. So I'm just going to graph this really quick just to show you what this looks like. This one is 0, 0, center. In the x direction, I'm going 5, left and right. In the y direction, I'm going 4, up and down, so that my graph is going to look like this for this problem. That's my ellipse. For this problem, this is my circle, 0, 0, and it looks like I'm going to go up 5, left 5, down 5, and right 5. So it looks like this problem right here looks like that. So obviously, I do see my two intersection points, which are 5, 0 and negative 5, 0. However, I would like you to prove that. And then the way you're going to prove that is you're going to plug in one equation into the other. And I'm just going to solve for x squared. So I'm going to take this top equation right here. I'm going to solve for x squared. So x squared is equal to negative y squared plus 25. And where I see an x squared, I'm going to plug this into the other equation. So we're going to go from this equation that says 16x squared plus 25y squared is equal to 400. Where I see the x squared, that's where I'm going to plug this value in right here. So let's see. We have 16 times x squared, which is this, minus y squared plus 25. plus 25y squared is equal to 400. So we're going to get negative 16y squared plus 400. 16 times 25 is 400, plus 25y squared is equal to, or actually, I'm going to subtract that right now. The 400 on the right, I'm going to move that over. So minus 400, because it is quadratic, and I do need to set it equal to 0. Oh, my 400s are going to cancel. See that? And I'm going to get negative 16y squared plus 25y squared is what? 9y squared, and that equals 0. And if I divide by both sides by 9, okay, I'm going to get y squared is equal to 0. But when I square root both sides, I get 0. Y equals 0. So what I need to do now is I need to plug y equals 0 into the other equation. And so the other equation being this one right here, or actually this one right here, because I just used this equation right here. I just used this problem. So we're going to go back up to this equation right here. And we're going to go x squared is equal to negative y squared. So that's negative 0 squared plus 25. So we're going to get x squared is equal to 25. So x is equal to plus or minus 5. When you square root both sides, you're going to get plus or minus, which gives me my positive 50 and my negative 50. So another system of equations, which is awesome. So that's it for hyperbolas. I hope you liked that lesson and learned from it. And I'll see you next time when we cover parabolas. All right, thanks for watching.